Hello everybody, I hope you guys are having a great evening. For tonight's video we're going to take another look at simplifying exponential expressions, or as the title here of our notes say, exponent properties take two. The first two properties that we're going to talk about we actually looked at yesterday and then reviewed a little bit more today in class. So the first one here is called product of powers, which tells us if we have two powers that have the same base, they must have identical bases. In this case, the bases are x to the m times x to the nth power. We simply add the exponents. So the solution here would be x to the m plus n. The other property that we were able to look at is called power of a power, and that tells us when we have one base that's raised to a power, but then that whole power or that exponential expression is also raised to another power, that we just multiply the two exponents here. So x to the a to the b becomes x to the a times b. I want you to take a look at these two examples down here, y to the third times y to the negative fifth times y to the eighth, and m to the fourth times m squared raised to the negative first time looking at negative exponents, and pause the video to try to get these taken care of. Alright, hopefully you paused it and were able to work these out. The answers here for example 1, it ends up being y to the sixth power. When we add all the exponents here, we're left with a power of 6. And the final solution here, when simplified, becomes m to the 14th. And actually with example 2, you're using power of a power first, then product of powers. Okay, moving on. On this next page, we're going to take a look at power of a product. And I guess I'll come back up here a little bit for those that are still getting these previous two answers. Power of a product we actually looked at yesterday in class and a little bit on the video last night, but we didn't really define it as a property. So our next exponent property tells us that if we have a base that's being multiplied, so really there's two terms in this monomial base, a times b raised to the mth power. Another way of looking at that could be ab to the power of m, and that simplifies to a to the m times b to the m. Or one way of looking at this is that every single term in here in this monomial, the a and the b, are both being raised to the power of m, and the parentheses here dictate that. They tell us where the base is. Looking at example 3, and then we'll go ahead and take a look down here also at a tougher one with example 4. Pause the video now and try to take these two examples down in your notes and work them out quietly. Alright, hopefully you're able to work these out. With these two, since they're a little bit more difficult, I'm actually going to help us out. The first one in example 3, we can look at expanding it first for those that are still not too comfortable with all of our properties. Writing in an expanded form, because we know that we have this term, 5x to the third y squared, twice. We have two factors of it. That squared right here tells us that. It becomes 5x to the third y squared times itself, 5x to the third y squared. So now we look at how many factors of 5 do we have? Well, we have one here and one here. That's 5 squared, or simply 25. How many factors of x? We have 3 factors of x here, 3 factors of x. It's not x to the 9th. Even though we're multiplying, we look at how many total factors. 3 here and 3 here gives us x to the 6th. And then how many total factors of y? Be y to the 4th. So that would be our final answer for that first example. Or you can simply look at the shortcut. You square everything in here. 5 squared becomes 25. X to the third squared, you multiply in that case, becomes x to the 6th. And y squared becomes y to the 4th. The last example down here for this new property is pretty difficult. Lots of things going on here. So again, let's take our time, but maybe move a little bit quicker. We're looking at squaring everything in this parentheses. So 4 squared, we know becomes 16. X to the second squared is x to the 4th. And then y squared is simply y squared. So we've taken care of that first term. Now, looking at this next one, we still have x to the 5th, a y squared, and we're multiplying all that by 2y. Now, because everything here is being multiplied, this is really 16 times x to the 4th times y squared, and then this is times x to the 5th times y squared times 2 times y. Everything here is being multiplied. We can use our commutative property and rearrange it. So it can really be 16 times 2, if we get our integers in front. Then we have x to the 4th and x to the 5th. Then we have y squared, and y. I'm running out of room here, but that's a y squared and a y. So we can simplify now to our final answer. 16 times 2 will give us 32. X to the 4th times x to the 5th gives us 9 powers of x, or 9 factors, I should say, x to the 9th power. And then y squared times y, well, 1, 2, 3, 4, 5 factors of y. So our final answer, 32x to the 9th, y to the 5th. All right, the last thing here is simplifying expressions, and these are our last two examples. Simplifying expressions is really what we've been doing all along, but it just tells us that we want to find the most simplest or the most shortest way, I guess, of writing our final answer. So pause the video now to work out example 5 and example 6, and then push play once you've got your answers. All right, hopefully you were able to work both of these out as you paused it. On example 5, this one looks a little bit harder than it is in my opinion. You can rewrite the first one. It becomes a to the 3rd, b to the 3rd, c to the 6th if we look at our power to a power. And then with this one, it becomes times a to the 4th and b squared. So how many factors of a do we have? There's 3 here, there's 4 here, that's a to the 7th. How many factors of b? We have 3 factors here, 2 factors here, b to the 5th, and then we still have c to the 6th power. Would be our final answer. This last one, I hope you like this fraction right here. Remember, fractions don't leave us. They'll be around forever. So with the first term, we have 5b squared to the 3rd. It becomes 5 to the 3rd, which is 5 times 5 times 5, I guess 125, and then b to the 6th, and we're multiplying that. Well, 1/2 is also being squared, so 1/2 squared is 1/2 times 1/2, 1/4, and then b to the 3rd squared becomes b to the 6th. So looking at our integers, or looking at our constants, I guess, we have 5 to the 3rd, which is 125, and we're multiplying that by 1/4. That's the same thing as 125 over 4. And then b to the 6th times b to the 6th is b to the 12th, because we have 12 factors. 12 factors there would be. All right, remember, you can always rewind or pause, go back and look at some other examples if you have any extra questions. Hopefully, you're starting to get the hang of these exponential expressions and simplifying. We got a little bit of a look at some negative exponents, but moving forward, we're going to really get some chances to do negative and zero exponents, some things to look forward to. Okay, have a great night, and I look forward to seeing you guys tomorrow.